So today we're going to set up the reaction of nButyl alcohol with our mixture of concentrated aqueous HBr and aqueous HCl, which is 48% aqueous HBr and 37% aqueous HCl. So I've already fetched a clamp from the clamp drawer, and I've already pulled out the stirring hot plate that we're going to need, along with the aluminum block and auxiliary blocks that we're going to use to heat our conical vial. So I'll plug that in and make sure it's working and turned off. Get that set. So we're going to need from drawer D a nice clean 5 milliliter conical vial. And we'll need a spin vane for that, with the pointy end down so it can hit the bottom of the vial. And we'll need a graduated cylinder for measuring the concentrated acids. You would normally be getting those concentrated acids from a burette, but since we don't have that set up, it's not worth setting up a burette just for one. And then we need an automatic pipetter that's set at 913 microliters. So this one is set at 913 microliters for dispensing the butanol. This other pipetter is for the 2-butyl alcohol reaction. And then I need a condenser. And I need to put a cap on there with an O-ring, so that'll create a tight seal. The cap goes on, and then the O-ring slides on so it goes above the joint, and that way it can't come off. So when we attach it to the vial is held in place. So it's a fairly simple setup. We're going to need our 2 pieces of amber tubing, right, with the larger of the diameters. So that's for the condenser hose. And since it's always easier to put that tubing on if you wet it a little first, I'm going to fill a beaker. And we can take this off since we're going to need to attach our hose to that. So that'll be our inlet hose. It'll go to the bottom end of the condenser. I'll get that on nice and tight so it doesn't fly off when we don't want it to. And then this will be our exit hose coming out the top. That way the condenser will fill completely. And then, as always, I'm going to put a weight on the bottom so that the hose can't come flying out when I don't want it to. And I like to flap that around the back so that I can see the actual flow. Yeah, it's getting a little twisted. Maybe untwist that a little bit. There. So we can start the cooling water, right? Since the cooling water is only going through the outer jacket, it's perfectly fine to start that. I can tilt it to get rid of the air bubbles. So our condenser is cold, and that's a reasonable flow. Maybe doesn't even need to be quite that strong. So we'll sit that there until we're ready for it. Actually, to be safe, let's clamp that. So we'll move this close enough we can fit that in there. And we'll eventually want that centered over the plate. And it looks like we'll be able to get that on there pretty well. Alright, so I'm going to put some gloves on to dispense the concentrated acids. Don't really want to get the concentrated acids on me. N-butanol will come from that. These two things are for the workup, sodium bicarbonate and the hexane, when we do our little extraction. You can see the concentrated acids are fuming a little bit. They reach the moist air. So we need 2.36 milliliters, which is about 2.4. But I'm going to be setting up 3 reactions today using this concentrated acid mixture. So I'm going to go ahead and measure all of it 3 times 2.4 or 7.2 milliliters. That way I won't have to keep measuring it out. And I'm going to use a pipette to dispense it so I don't spill it in the attempt to pour it. And then I'll use that same pipette to transfer it to the vial. There's not much liquid in this bottle, so it's a little bit of a challenge. And each one of those lines is 0.1. So I've got my 7.2 milliliters of acid. That'll allow me to set up 3 reactions. And I'm using this little Erlenmeyer flask just to hold the pipette so the pipette tip doesn't get contaminated. So now we want to put 2.4 milliliters of the concentrated acid mixture into our 5 milliliter conical vial. Notice I'm holding them close together so I don't have to move the pipette very much. Right, and 7.2 minus 2.4 will take us down to 4.8 milliliters. You'll notice it says it's 3 milliliters in there, but there's the volume that's being occupied by the spin vane. So we'll set that 4.8 milliliters aside for the other reactions that we're going to set up later. And at this point, I think I'll dispense with the gloves. So we need 913 microliters of nButanol, and if you're not familiar with these auto pipetters, there's kind of the first time it hits, right? That's the where you want to go to fill it, and then there's a second little one where you can press it a little harder, and that'll get the last piece out. So we'll press it down to the first stop. Slowly pull up our 913 microliters of nButanol, and then we'll add that down the side. It's going to float and it's going to generate a little bit of heat, and then just to get that little bit out of the tip, I press it down to the second stop, and then if you press it really hard, right, fall out, and then this dispenses my tip. I can get rid of that tip, and that way I can set this down. You never want to set this down horizontal when there's a tip attached because you'll contaminate it. That's my nButyl all measured out. And now I'm going to attach this vial to the bottom of the condenser and screw that tight so the vial won't come out. And I can lower the assembly, lower that vial into the hot block, and turn on the stirrer to a setting of about 600. That'll stir it nice and vigorously, and if I have it centered it should say stirring. And then I want to heat this up to about 140 so it starts refluxing, and that will require a setting of maybe 180 on the hot plate. I'm going to put a thermometer in there so I can monitor the temperature of the block. And I'm going to actually tilt this a little bit so I can put the thermometer back behind so it's out of the way and it doesn't, no risk of breaking it. And we'll just let that heat until it heads up to about 140. I'm going to get a spatula at the ready, one of the medium-sized spatulas. I don't need it to be bent, which will allow me to move that block around without hurting myself later. So that's really all there is to the setup of this reaction. And it's just going to need to reflux for 90 minutes. Once it starts the reflux process, we'll set our timer. Take a look at the clock. I'm going to pull those out so I can actually see it when it starts boiling. And it's okay to crank this up, maybe to 200 or 225 just to let it heat quickly, and then we'll turn it back down. Usually for a spin vane in a conical vial, I set it at about 600 on the stir plate. And if I'm doing a stir bar in the bottom of a round bottom flask, I set it at about 450. Those seem to be good settings. The temperature here, reading, is not going to be accurate for the temperature inside the vial. So it always has to be set a little higher than the temperature you're actually trying to achieve. So we'll just let that heat. Got a good flow rate. That looks like it'll keep going nicely. And we're up to about 50 so far. So this other pipetter is slightly different design. It's set at 950 microliters, and it has just one control. It doesn't have that separate tip ejector like this one does. So it has one stop. The first stop is where you go when you're filling, and then the second stop to depress the lead a little bit. And if you press it really hard, that moves this piece here and actually takes your tip all the way off. So we're going to use that one, which is set to 950 microliters when we do the reaction with the T-butyl alcohol. T-butyl alcohol is a solid sometimes at room temperature. Looks like it's warm enough today that that's actually liquid, so we don't have to heat that. Sometimes you have to heat that in a water bath to get it to behave itself. We're up at 70 so far. Take a little while to get that up to temperature. I'm going to make the T-butyl alcohol a separate video so you can watch it independently. But normally, while I'm waiting for these things, I would be measuring out my 0.2 grams of sodium carbonate and getting things set up for the next reaction. Since this has to reflux for 90 minutes, that'll be plenty of time to set up and complete the reactions of the T-butyl alcohol while we're waiting for it. Set that as a reminder that the block is hot. It shouldn't be touched. One thing about these sinks is they have a tendency to turn themselves off if you turn them down too low. So that's why I like to have the water where I can see it, rather than sticking it all the way down into the sink. See that the thermometer's up at 120 now. We don't see any bubbling yet, but we will shortly. nButyl boils at about 118 degrees. And nButyl is the longest or the shortest chain alcohol that's not fully miscible with water. Propanol, isopropanol are fully miscible with water, but nButyl, you can actually have it float on top, and you saw that it was floating on top until I began the stirring. So I need to stir this fairly vigorously in order to make sure that the nButyl and the concentrated acids mix well. Otherwise it'd be a two-phase mixture. So you can start to see that there's definitely vapor kind of condensing the top of the vial. We're getting up close to 140.